So that is the derivative. But here, this was like, I was trying to make them match. I was assuming that as x plus 1, just the base, not the exponent. I was assuming that as x plus 1, that as u, right? And then you were able to write this is u to the n. If you do that, you were able to write u to the n, right? And when you find out the derivative, you're trying to find out the derivative of u to the n, right? So derivative of u to the n. So what did we do? The derivative of u to the n was, it was like, we were using, on this part, we were using, from here to here, we were using n times u to the n minus 1 times, and that part is basically u prime, right? Times u prime. That's what I was using. So that is the now updated power rule. Look at this. These are the formula, right? Du to the n over dx. Look at that. They don't match here, right? There is u, there is x. If they don't match, then this is the formula you use. Okay, what we did is we made them matching. You did du to the n over du times du over dx. If you cancel that, you will basically get that thing. So you divide it and multiply by du. You can think that way. Okay, so what is the formula there? The first one has formula, because you can use the power rule here, u to the n and then u. So they match here. Now, so you can use the power rule. When they match, you can use the power rule, n u to the n minus 1 times, this is basically u prime, the derivative of u with respect to x. So what you can think here is, look at this. If the base do not match, if that u do not match with that one, then what we do is you use the power rule here. Basically, you use the power rule times the extra thing that you do is u prime times the u prime. Don't forget that. Okay, that will be times the u prime is the extra thing we will need, because you remember that if you have dxn over dx, see, they match. If they match, then you can do nx n minus 1, because they match. These two bases match. Okay, but if they don't match, then what we do? Du to the n over dx. They don't match here, right? You see that? There is u, there is x. In this case, what you do is you still use nu n minus 1. Why don't you have x? Because the base was x here. That's why I wrote the base. Here the base was u. That's why I wrote the base. Times the extra thing you need is u prime. That is the extra thing you need. Okay. So if they do not match, if that value is different from x, then we have to multiply when you find the derivative, we have to multiply the extra u prime. Okay, that is the main thing on the chain rule. Okay, so let us see some other formula there. So what are the other formula there? Okay, let us see the second formula. D sine u over du. Okay, look at that. What is the formula for d sine x? D sine x over dx. Look at that. Here they match, right? Here this x and x match. So in that case, the formula was cosine of x. You see that? But here they don't match. There is u, there is x. So what is the formula then? The formula is you try to make them match. D sine u over du. You are making them match, but this is the extra thing. So I multiplied by du, and then over dx is that same dx. Now this one, they match, right? That u and u match. So you can write cosine u, that is the derivative of sine u, times du over dx. That is the extra thing. That is times u prime is the extra thing. Did you understand that? Okay. So therefore, if you have d sine u over dx, then that will be cosine of u, because the derivative of sine u is cosine u, times, because they don't match, I multiply by the extra u prime. You understand that? So if they don't match, if the variable on the top and the bottom don't match, then what we do is we try to make them match. And you don't have to show this middle term here, middle step here. Okay, you can just write the first equals to the last. So the derivative of sine is cosine u, okay, times, since they don't match, we need to do u prime. Look at that cosine u. What is the derivative of cosine u? Is negative sine u, but since there is u, that prime is the derivative with respect to x. Think that way, okay? This prime is with respect to x. This assumes that there is dx in the denominator, okay? So since there is u, not x, then we write negative sine u is the derivative of cosine u times u prime. So can you think of the derivative of tangent u? What is the derivative of tangent x? That is secant square x. So tangent u will have secant square u times, since there is u, there is no x. If it was x, the formula will be secant squared x only. Since there is u, you write u prime. You understand? Now let's look at the secant u. So what is the derivative of secant u? Secant u is secant u times tangent u times, since there is no x, there is just u, we are finding the derivative with respect to x. That prime represents with respect to x or with respect to t, whatever. Okay, since there is u, then you do times u prime. Okay, similarly for cosecant, it is minus cosecant u. Let me write c as c. Cosecant u times cotangent u times u prime, and cotangent u is negative cosecant square u times the u prime. Okay, so this is how we just, this is nothing new. Okay, we have the formula of all these trig ratios already, and we have the formula for this. Only the difference is if that base or that angle is different from x and you are finding with respect to x, if that angle is u but you are finding with respect to x, then you need to multiply by, you write the same formula as before and you need to multiply by u prime. That is the new thing we are doing. Okay, let us see this example. We have y equals to 5 times 1 minus 2x to the fourth. Okay, so I don't want to FOIL that 1 minus 2x to the fourth. I want to use the chain rule. Okay, so find y prime. So how do I do this? What I want to do here is I want to set u equals to 1 minus 2x, not with the exponent, just the base. Okay, set u equals to 1 minus 2x to just 1 minus 2x. Then you can write y equals to how much? 5u to the fourth. Okay, now I want to find out the derivative. So it is like 5 times u to the fourth, right? Since this is just 5, you can pull that out. So what is y prime? Y prime is 5 times the derivative of u to the fourth, right? It is like u to the fourth prime. So you can pull that 5 out. This is just a constant, so you can pull that out. Now we need to find out the derivative of u to the 4 prime. This prime stands for derivative with respect to x, because that is x there, right? Now how do I do that? Is 5 times, use the power rule. It is 4 times u times 4 minus 1 times u prime. That is the extra thing we will need because we have u there, we don't have x there. That is the reason. Okay, so how much is that? That is basically 20 u to the 3 times, what is u prime? You find out the derivative of that, right? If set u equals to 1 minus 2x, then what will be u prime? You need to find out u prime equals, derivative of 1 is 0 minus derivative of negative 2x is negative 2 u, and then derivative of negative 2x is negative 2 times derivative of x is 1, right? So that will be negative 2. That's what you get, right? So times negative, I'm sorry, let me write that form, times negative 2, times negative 2. Now, but your question was in terms of x, so you want to write your final answer in terms of x. So 20 times negative 2 is negative 40 times u is 1 minus 2x to the 3, u to the third. That is the final answer. Okay, so it was a lot easier. This chain rule made the problem very, very easy. Okay guys, so we will do many examples so that you will be used to with this chain rule.